Alrighty. Before we begin today's lecture, I want to show you the type of thinking we're going to be doing in the problems we're going to be working today. So I just want to give you an example of how our brains are going to be working, what type of thinking we're going to be doing. If I give you an equation like this that said x squared is equal to 25 and asked you to give me a value that would make it true, you could easily tell me, well, that value, the number that I would square to give me 25 would be 5. That's pretty easy. 5 times 5 is 25. But there's another value if you stop and think about it. If I plug in a 5 right here, 5 squared, that's 5 times 5, is 25. But what if I plugged in a negative 5? If I plug in a negative 5 right here, negative 5 times negative 5 is also 25 because negative times negative is positive. So actually, when I take the square root of both sides, that's how we would solve this. I would say, well, the square root of this is going to be x, and the square root of 25 is going to be 5. But within the context of an equation, there are going to be two possibilities. There could be a positive 5 or a negative 5 that will make this original equation true. If I plug in a positive 5, 5 squared is 25. If I plug in a negative 5, as long as you do it with a calculator and put it in parentheses, you get the right value. Negative 5 times negative 5 is also 25. So what we're going to be doing is taking the square root of both sides of an equation to get rid of this little exponent here. To get rid of a squared, we take the square root. And the resultant equation is going to have a potential of 2 solutions here. So let's take a look at this one real quick. This is how we're thinking. So I want to find the value that will make this true. So I'm going to take, let's say I didn't know there would be 7. I would take the square root of both sides. In rewriting this, the square root of x squared is x. And this would give me plus or minus the square root of 49, which I happen to know is 7. So that gives me 2 solutions that will make this true. Positive 7 I could plug in here, or a negative 7. So when we take the square root of both sides within the context of an equation, we're going to have 2 potential answers. Right? What if I have a binomial that's squared and I want to solve this? Well, I still get rid of this by taking the square root of both sides. In doing that, this square will disappear. That's what this radical does. They kind of cancel each other out, so to speak. And we have x plus 1 is equal to plus or minus the square root of 25. And then I could go ahead and solve this thing. This would be x, subtract 1 from both sides. I'd have equals negative 1 plus or minus 5. And this will give me 2 answers. X equals negative 1 plus 5 is 4, or negative 1 minus 5, which is negative 6. That plus or minus can be written in 2 statements. X equals negative 1 plus 5, or x equals negative 1 minus 5. That's what this means, negative 1 plus 5, or negative 1 minus 5. And that's where we would get 2 solutions there. Okay? And one more I'll do that it doesn't come out from under the radical. These come out from under the radical because we know they're perfect squares and we can easily find the values that come out from under the radical, so to speak. This one won't. I'm going to do the same thing to both sides. I'm going to take the square root. This will give me x plus 1, because this radical symbol will cancel that exponent, is equal to plus or minus radical 17. To solve this, I'll just subtract 1 from both sides. Let me scooch this down so you can see it a little bit. X equals, subtracting 1 from both sides, x equals negative 1 plus or minus radical 17. I personally leave my answers like this. Sometimes you'll see them written individually, negative 1 plus radical 17, or x equals negative 1 minus radical 17. On most of the standardized tests I've taken, they leave it as one statement that implies 2 solutions. Sometimes you'll see it written in 2 solutions. I think on today's answer sheet, it'll be broken into 2 solutions. Okay, so this is the type of thinking we're going to have to do to do the problems we're going to be doing today. And that brings us to our lecture. Yay. So here we go. Algebra 2 OASA 2A11, the student will solve quadratic equations by completing the square. This is lecture 1028 and 1029. So here we go. Let's see if we can get this to make sense. Bear in mind what I just said. To solve by completing the square, we must make sure that the coefficient of the quadratic term, that's whatever the number is in front of a square, the coefficient of the quadratic term is 1. If it's not 1, we're going to change it to 1. And I'll show you how to do that. Solve by completing the square. To complete the square, if we have an equation, now yesterday, for the last couple of days, we've been completing the square, there's no equal sign. Today we're going to solve by completing the square, and here's how you do it. We want to get this m squared and m, these two variable terms, by themselves. So I'm going to get rid of this positive 32 by subtracting 32 from both sides. M squared minus 10m is equal to, and I'm subtracting 32 from both sides. And 9 minus 32, I'm going to use my handy dandy pocket brain so I don't mess up. 9 minus 32 equals, yay, negative 23. So all I've done so far is, get the variables by themselves. I want to isolate these variables. Now I'm going to complete the square just like we did yesterday. I'm going to take half of this one, which is 5, and square it, and add it here. And because it's an equation, I've got to add the same thing to the other side. So I'm going to take half of 5, which is, half of 10, which is 5, square it, which is 25, and add that to both sides. Move this over a little bit this way. Now I'm going to factor this side, just like we did yesterday and the day before. This will give me m minus half of this squared equals 2. Okay, so I wrote this as the square of a binomial. If I did that too quickly, you can think of it as doing this. Square root of this one, here and here. Factors of 25 that add up to 10 would be 5 and 5. And they've got to add up to negative 10, so they both be negative. Okay, and m minus 5 times m minus 5 is m minus 5 quantity squared. Alrighty? So that's where this came from. I just took half of this number, put it here, square of a binomial, just like we did for the last couple of days. But now we're going to solve an equation. I've got this chunk squared is equal to 2. I want to take the square root of both sides to get rid of this. When I do that, this squared disappears and I'm no longer in need of these parentheses. On this side, however, because I'm within the context of an equation, it's going to be plus or minus, and I don't know the square root of 2. It's an irrational number, so I'm going to just represent it as radical 2. Then to solve this, it'll be m. I'm going to add 5 to both sides. And our final answer will be 5 plus or minus radical 2. And on today's answer sheet, it'll probably list it like this. M equals 5 plus radical 2, or m equals 5 minus radical 2. 5 plus or minus radical 2, this is how I usually leave my own answers when I'm solving these types of equations. But what that means is 5 plus radical 2 or 5 minus radical 2. And I'm thinking that today's answers are going to be written like that. Okay? Let's do a couple more just to see how it works. It's basically the same pattern over and over again. I want to isolate my two variable terms, so I'm going to add 73 to both sides. That's the first thing I want to do, is isolate those variable terms. Then I'm going to say x squared plus 8x is equal to, what is that, 78? And then I'm going to complete the square just like we did for the last couple of days. Take half of this value, square it, and add it to both sides. Well, half of 8 is 4. 4 squared is 16. So I'm going to say, well, plus 16 plus 16. I'm going to write this as a square of a binomial. Now watch what I do. I take the square root of this one, I take this sign, and I take half of this number, and it's squared. That keeps me from having to factor like we did here. It'll be half of this one every time. Okay? Just like we talked about for the last couple of days. 78 plus 16 is whatever 78 plus 16 is. 94. I'm going to take the square root of both sides. Plus or minus radical 94. And 94 doesn't have any perfect squares in it, so your calculator, your TI, whatever it's called, TI-30XS, when you go to use it to simplify this radical, it'll just read radical 94. It won't simplify it for you because there's not a perfect square in there to pull out from under the radical. So it'll just represent it like this. You have to remember to put the plus or minus there. And therefore, to solve this, we now subtract 4 from both sides. And we wind up with, I'll bring this up a little bit. X is equal to negative 4 plus or minus radical 94. And in your answer choices, it'll represent it as two equations. X equals negative 4 plus radical 94, or X equals negative 4 minus radical 94. This is how, I'm nearly certain that's how it's written in the answer key. Because I think I saw that a couple days ago when I was looking at them. Okay? But this says the same thing as these two statements. Okay? I hope that's making sense. We'll do another one or two. I think it's just one more. Oh yeah, here's what, remember up here it said this, I should have underlined it. To solve by completing the square, we must make sure that the coefficient of the quadratic term, that's the term that's being raised to the second power, this coefficient, that's the number that's being multiplied by the quadratic, by the exponent that's raised to the second power, this coefficient has to be a 1. So if it's not, we're going to turn it into 1. So here we go. I'm going to, first of all, isolate my variables by adding 71 to both sides. This will give me 4x squared minus 8x is equal to 71 minus 7. Because my brain isn't working very good today, I'm going to use my calculator. 64, hey, all right. And now, before I can complete the square, this has to be a 1. So I'm going to divide this by 4, which means I've got to divide everything by 4. I've got to divide the entire equation by 4. So I'm dividing this side of the equation by 4, and I'm dividing this by 4. So here I go. Dividing this by 4 is x squared. Dividing this by 4 is 2x. Dividing this by 4 is 16. Now, my coefficient of my quadratic term is a 1, and now I can complete the square. To complete the square, I take half of this number, which is negative 1. I square it, which is 1, and I add it to both sides. I now rewrite this as the square of a binomial. I'm going to complete the square and write this as x minus half of this number, just like we talked about for the last couple of days. That's equal to 17. 16 plus 1. Now I'm going to take the square root of both sides to get rid of this. This will give me x minus 1 all by itself because this radical canceled out that exponent, so to speak. And this gives me plus or minus, and I'm going to leave the 17 under the radical because that's an irrational number. It doesn't have a perfect square to come out from under the radical. Then I just add 1 to both sides. X is equal to 1 plus or minus radical 17. I added 1 to both sides. 1 plus or minus radical 17. And as I said earlier, this in your answer sheet will probably be represented as 1 plus radical 17 or 1 minus radical 17. It'll break it into two statements. X equals 1 plus radical 17 or x equals 1 minus radical 17. That's what this means. Okay? Those are the types of problems we're going to be doing today. Hopefully that makes sense. And I will be happy to help you, of course, as you're working them throughout the course of the day. Best of luck. I know you can do this.